So we will continue doing problems on chapter 2 together. Last time we stopped here. We have finished together doing problem 2. Okay, so we'll start with problem 3. For each pair, indicate which bond will be stronger. So first we need to determine which bond is stronger between CH and LEF. So first, what is the type of bonding between C and H? Yes, very good. It's covalent. Why? Because if you remember, C has 4 valence electrons, okay? And so in general, for atoms with more than 4 number of valence electron, they will do a covalent bonding. Now H is an exception because H, it's true that it has only one valence electron, but we know that H has only one orbit. So H is a particular case where we have one electrons of valence, but it's doing covalent bonding since for the first orbit the number of stable configuration is 2 electrons. Okay, so here we'll have a covalent bonding, okay, between C and H. On the other hand, for LE and F, to know the type of bonding between them, let us look at the periodic table. So if we go to the periodic table, this is LE. So for LE, we have LE is in group 1A, so it has 1 electron on its outer orbit, and F is in group 7A, so it has 7 electrons on its outer orbit. So what will happen here is that Le tends to lose 1 electron, while F tends to gain 1 electron. So we will have 2 ions, Le plus and F minus, which have opposite charges. So yes, as you said, it's an ionic bond between them. Okay, so here, if we just want to put the explanation, so we say that Le has 1 electron on its outer orbit. So what is the difference between H and Le? Why Le will tend to become an ion while H tends to do covalent bonding? Because look, if you look in your table, H has only 1 electron. So if I present H, if I put the planetary model for H, it's just 1 electron and it needs 1 more electron to close the full set, which is 2. However, for Le, it's different because for Le it has 2 orbits. Okay, so Le has already a first orbit having 2 electrons and a second one having only 1. So what will happen is that Le, when it will lose 1 electron, it will reach the stable state, because the second orbit to be stable should have 8 electrons, which is very far from 1. This is why Le tends to lose this electron, while H tends to gain an electron. Okay, so here we say that this is why, just to tell you, this is why H, as you can see here, even if it has 1 electron on its outer orbit, they put it in group 7. They put it in group 7 because it has a behavior similar to the atoms having 7 electrons on their outer orbit. Okay, so when we say that in general the first group 1A elements are metals, okay, we don't include hydrogen. So hydrogen is not a metal. Okay, it is a non-metal. Okay, so going back to the set of problems. So we say Le has one electron on its outer orbit, which is number 2 orbit. So on its outer second orbit, okay. So it will tend to lose this electron to be stable, okay. So it tends to lose this electron, okay. While F, on the other hand, since F, while F is in group 7, okay, so 7A, so it has 7 valence electrons, so it has 7 valence electrons and tends to gain 1 electron, okay, to have F minus, to reach F minus. So the compound will be Le plus F minus. And now, which one is stronger, the bond between CH or the bond between Le and F?
The ionic bond.
Very good. So ionic bond is stronger than the covalent bond because you have creation of electrostatic forces that will attract opposite charges. So this is a high force. So in general, an ionic bond is stronger than a covalent bond. Now, the second comparison will be between two cases, LEF and MgO. So LEF is already done. It gives us the ionic compound Le plus F minus. Now for MgO, to know what type of bonding is between them, we'll go to the periodic table. As we can see, we have Mg in group 2, okay, and O in group 6. So here, Mg will tend to lose 2 electrons, while O will tend to gain 2 electrons. So we will have the case of Mg 2 plus so Mg 2 plus, okay, and O 2 minus, okay. Now, which will be stronger, Mg 2 plus O 2 minus or Le plus F minus? Why LEF is stronger, Ali? You should justify your.
G is stronger.
Because it has a greater ionic percentage character
No, look, in general,
of the electronegativity.
it's true that it has a higher electronegativity, but the idea here is that in Mg2 plus or 2 minus, you have 2 positive charges and 2 negative charges. So in general, what is dominant in this case will be the number of opposing charges. So since you have 2 opposed charges, it will give you a more strong bonding than in the case of LEF. Okay, you compare electronegativity in case both will have the same number of charges, opposed charges. Okay, but here, since MgO has a higher number of opposed charges, which is 2, while in LEF it's for each one it's 1. Okay, then MgO will be stronger. Okay, so the first criteria to compare is the number of opposed charges. If it is higher in this case it's higher in case of MgO because we have 2 opposed charges, while in LEF we have 1. Now, in case, as I mentioned before, in case you have the same number of opposed charges, then you compare electronegativity. So whenever you have an atom that is more electronegative, then in this case you can say that the bond will be strong. Okay. Jana, in the exam, okay, in the exam, Jana, you can just put the group. So you say Le is group 1. So it will give us ion Le plus, and F group 7 will give us ion F minus, and the compound is Le plus F minus. So in a very short way, you can elaborate this. Okay. Okay. So now let us go to another problem. Problem 4. In problem 4, give the Lewis dot symbol for the following and how many electrons can each atom accommodate. So, of course, in order to know the number of valence electrons, we go to the periodic table. Okay, so from the periodic table, SE is here. So this is SE. It is in which group? I just look at the group. It's a group 6. Since it's a group 6, so it has 6 valence electrons. So in order to represent, to give the Lewis presentation for it, so I just put for SE 6 electrons on its outer orbit. So it will be like this: 1, 2, 3, 4, and 7, 6. Okay, and SE. Who will give me an example of if I have the molecule Se2, it will be which type of bonding? Or Se oxygen, Se with oxygen?
Covalent.
Of course, if I combine Se with oxygen, it will be a covalent bonding because Se needs 2 more electrons to close the set of 8, and oxygen also needs 2 electrons to close the set. So it will be a double bond. I will have a double bond, and it can share it with O or with another Se. So it can be any other atom in group 6, or it can be 2 atoms from group 7. Okay, so I can have I can have Se with, for example, 2F. Okay, because each F will share 1 electron. So I have several possibilities here to select the other atoms. I have a wide range of possible bondings. Okay, now the other example, the other atom for which they want me to represent, to give the Lewis presentation, is krypton. And krypton is here. It is in group 8. Okay, so for krypton, which is in group 8, it has 8 valence electrons. So if I want to represent it, so this is Kr with 8 electrons. So it's a very stable atom. This is why group 8A, this group is called noble gases, since they don't need to interact with any other atom, that they are already stable. Okay, so this is the Lewis presentation for krypton. It already has a set of 8, so it's already stable. But who can tell me what type of interaction can be if I want to form a molecule of, for example, Kr2, what will be the type of interaction between them? It will be atom to atom interaction or molecule to molecule interaction? No, no.
Atom to atom.
It's not metallic. Look why? Because metallic is between metals. So to have metallic bonding, you should have several atoms, and all of them should have low number of electrons on their outer shell. Then they will have the electrons on the outer shells of these metals will tend to be shared by all the atoms, which will create a certain cloud of electrons permeating the entire blocks of atoms. Okay, so in this case, first, when I have an atom of group 8, it will not have an atom to atom bonding, because what are the types of atom to atom bonding? Covalent, and Kr cannot do covalent bonding because already it is stable. So why he will do covalent bonding? Why to share electrons? Okay, it will not be ionic because it will not tend to lose or gain electrons. Okay, and it will not be metallic as we said. So what will happen? It's like we will treat it as a molecule. So any atom of group 8 will be treated as a molecule, and it can interact with other molecules Kr. Yani if I have Kr atom and I have another Kr atom, they can interact with each other through a type of molecule bonding. Okay, and which of the types of molecule bonding will be? Look, let us go back to the definition of the different types. Yes, when an atom has saturated electrons, no bonding occurs. Because why? In general, why we have bonding? Because this atom is trying to reach the stable set. But since this atom is already stable, why it will do covalent bonding with other? No need. Okay. So whenever it have a stable set, it will not interact with other atoms. Okay. So now, to know what is the type of bonding that is possible between two Kr atoms, let us go back to the definitions. We have several types of molecules bonding. So if we go back to molecule bonding types, the first type is London forces, and it states the following, that it's an attractive force between nonpolar molecules, which are atoms in molecules that are not forming dipoles. So this is the case here. Look, if you have an atom with 8 electrons on its outer orbit, which is a stable set, the only reason that can create a certain attraction with other atoms is temporary dipoles formed due to motion of electrons. Because it's true that you have 8 electrons on the outer orbit, okay, but they are not always dispersed in a uniform way. If they are dispersed in a uniform way, then you have a very balanced atom, so it will never tend to do any attraction with others. On the other hand, when you have rapid motion, this might lead to a new dispersion of electrons. So for example here, as you can see, in this atom or in this molecule, it can be a molecule also, not only an atom, okay? In this case, what will happen is that this side will be more negative than the other side, okay? So due to displacement of electrons, you can create in the same, if you look at this as a whole, it's balanced. But if you take, due to the non-symmetry, you can say that I have a side that is more negative than the other. So it's like a dipole. It's a formation of temporary dipoles. So in this case, what will happen, the negative side will tend to attract the positive side of the other atom. Okay, so London forces are very common between inert gases, because when they move, okay, we will have a new distribution of electrons. So we might have attraction between negative sides and positive sides. Okay, so we will have, as we say, it's formation of temporary dipoles, but it is a weak attraction, because it's not permanent. So when the atoms move, the position of electrons will change. So this attraction is not very strong. Okay, so this is London forces. So London forces are very common between noble gases. Okay,
Doctor,
yeah.
are these common forces إنه London forces بتصير بكل المولكيولز ولا بس وقت نحن بدنا نعمل like a molecule of
it's the most common type, London forces, because whenever you have a molecule or atoms in motion, you will have a new dispersion of electrons, and this non-symmetrical dispersion can create London forces. But it is one of the weakest types of bonding, because it's not permanent. Okay. On the other hand, for example, if you take the other type is dipole forces. This is a stronger connection. Why? Because it will take place whenever you have, for example, in molecule HCl. It's true that electrons are shared by H and Cl. So each one will have a stable set. But if you look at the hydrogen atom, the 2 electrons will be from one side. Because look, these are the 2 shared electrons. Okay, they are from one side of H. This will create what? It will create a positive side. So here, always the side will be positive. So here it's more permanent. This is why this is called dipole forces. It's stronger than London forces, because when you have this this molecule, always this side will be positive, while the other side will be the side of Cl minus will be more negative. This is why if you have several molecules HCl, what will happen is, since H nucleus will always have a side that is positive, so we call this is called a polar molecule. Okay, so here it's a positive dipole from this side, while from the side of Cl it's a negative dipole. So what will happen? You will have an attraction between the positive and negative dipole. Okay, so that's it. As a whole, your molecule is balanced, it's true. But if you divide your molecule, one side, this is called the dipoles. One side is charged in a positive, it's more positive, while the other side is more negative. So this will you will tend to have attractions between positive and negative sides. Okay. Okay. So if we continue here, going back to our question, we were saying that in the periodic table, okay, so here we were talking about the type of interaction for 2 atoms. So if I have Kr and Kr, I tend to have London forces between these molecules. Okay, so let us continue problems. Question 5. Based on Lewis dot symbols, predict the ion that can result from Be, F, B, and Cs. Okay, so here, of course, it's an easy question. The thing that I should do, I should check the number of valence electrons on the outer orbit. Okay, so once I know the number of valence electrons, I can deduce what is the ion that can be formed. Okay, so let us start by Be. So if we go to our table, okay, Be is, where is Be? Be is here. This is Be. Be is in group 2A. Okay, so since it is in group 2A, it will have two electrons on its outer orbit. So it will tend to lose these electrons to give what? To give ion Be2 plus. And if I want to represent the planetary model for the electron, so what will happen is the following. If I take the atom first, the atom Be, atom Be has 2 orbits, 1 and 2. Okay, it has 2 electrons on the first orbit and 2 electrons on the outer orbit. Okay, so what will happen now when it becomes an ion Be2 plus? So Be2 plus will just have 1 orbit, okay, because no more electrons to form in the second orbit. So this is Be2 plus. This is its representation. So it has 2 valence electrons, Be2 plus. Okay, and it will only have 1 orbit. Okay, so the ion resulting from Be will be Be2 plus. Okay, to continue, we have the other cases to study. We have F, B, and Cs. So going back to the table, F is here. F is in group 7. Okay, so since it's in group 7A, it has 7 valence electrons. So it will tend to gain 1 electron to reach the stable set of 8. Okay, this is why for F, if I want to show the planetary model for F, it has two orbits. Okay, on the first one we have 2 electrons. On the outer one we have 7 electrons. Okay, and to be stable, it will tend to gain an electron. So before reaching the stable set, this is its configuration. So 1, 2, 3, 4, 5, 6, and 7. Okay, and once it become F minus, so when it will gain 1 electron, the F minus planetary model will be like this. I will add 1 electron to F. Okay, it will become F minus, and therefore the ion formed from F is F minus. Okay, now the remaining ones we have CS. As you can see here, CS is in group 1A, so it has 1 electron on its outer orbit, and therefore it will tend to lose this electron to give ion what? The resulting ion will be CS plus. Okay, and finally for B atom, B is in group 3A. Okay, so it will tend to give which ion? Which ion will result from B? Exactly. Yes, very good. It's B3 plus. Okay, because B is in group 3A, so it has 3 valence electron. And whenever the number of electrons is lower than 4, then except for hydrogen, as we talked before, it will tend to lose its electrons to reach a stable set of 8, and therefore the resulting ion here will be B3 plus. Okay, so the resulting will be B3 plus. Okay, any question on this? Okay.
Doctor, we're not gonna cover the transition.
No.
شو اسمه؟
Yes,
بالنص.
this part you are not responsible of it, okay, because it's more chemistry details, okay, and you are not responsible of this part. I will always give you atoms in groups in A group, so it's enough for you to know the number of the group, okay, to know the number of valence electrons. So don't worry about this zone here. Not يعني mainly مش transition zone. It's fine if I give it for you because it's in this part. So but you are not responsible of this part here. What is happening here? It's fine. We will not get into these details. Okay.
Yes, okay. بعد سؤال.
Yeah.
Group 4 atoms, do they lose the electrons, or it's case by case?
Group 4 in general they tend to do covalent bonding. يعني they do not become ion لأنه هن just in the middle case. يعني
Okay, I got it.
So in general, these atoms will do covalent, not ionic. The atoms which will do ionic bonding are from groups 1 to 3, they will lose, and groups 5, 6, 7, they will gain. Okay.
Okay, thank you, Doctor.
Whenever you combine one atom from 1 to 3 with other atoms from 5, 6, 7, it will be ionic bonding. While when you combine atoms from groups 4, 5, 7 together, 4, 5, 6, 7, they will do covalent bonding together. And if you combine atoms from groups 1A to A, 3A together, they will tend to do metallic bonding. Okay? So these are the common 3 types. Metallic between atoms together of 1, 2, 3. Covalent between atoms together of 4, 5, 6, 7. And ionic if you combine atoms from 1 to 3 with atoms from 5, 6, 7. Okay? And concerning 8, as we said, group 8 is stable. So it can only, in general, it will only do London. It will only do London forces. Okay, because in general that they are stable, but just when you have rapid motion, you might have a new reposition of electrons, which will lead to formation of temporary dipoles. Okay? So let us continue. Now, problem 6. Draw the Lewis electron structure for the following cases. So first, I will start by Br2. Okay? We have already shown together in the periodic table that Br is in group 7. Okay, so since Br is in group 7, if I represent for this atom the Lewis electron structure, it will be like this. So this is Br. So it has 7 electrons. So 7 valence electrons since it's in group 7a. Now, if I have another atom Br close to it, what will be the type of connection between them? Which type of bonding? Of course, yes, true. It's covalent bonding, okay? Because they will share their electrons, their 7th electron, to form for each one 8 electrons, okay? So if I want to draw now for this one, it's 1, 2, 3, 4, 5, and 6. This is 7. Now, when I do my count now after the covalent bond between them, these 2 electrons will be common, so they will be counted for both. Okay. So now, if I count for Br, I have 1, 2, 3, 4, 5, 6, and 7, 8. The same for the other molecule. Okay. So it's 1, 2, 3, 4, 5, 6, and 7, 8. Okay. So I reached, in this case, the stable set of 8 electrons on the outer shell, and it's fine for me. Now, for CH3Br, okay, I have 3 atoms involved, Br, H, and C. Okay, I will try to see Br will be connected with one. Br need to connect with one atom because it needs only to share 1 electron. So in your opinion, it will share with H or with C? Yes, very good. It will share with C. Why? Because let us try. If it will share with H, what will happen? If Br will share with H, it will reach a stable configuration, and we don't have any more a place for C. Because if I put H here, what will happen is that H will reach a stable configuration because it has 2 electrons on its outer orbit, and Br also is stable because it has 8 electrons on its outer orbit. So C will not have a place. Okay, this is why here, since my molecule involves C, I cannot put the connection between Br and H. So I should put the connection between Br and C. Okay, and to do so, I will put here C. And I know that C has 4 valence electrons. Okay, so it can form 4 bonds with other atoms. The first bond will be with Br. Okay, and the 3 other covalent bonding will be with H, since as you can see in the molecule, it's CH3Br. So I can allow for 3 connections with H and 1 connection with Br. Okay, so here I still have the 3 other valence electrons, which will be shared with H atoms. So I'll have this 1, 2, and 3. And in this case, to verify my result, I can count the number of valence electrons for each atom and verify that it is equal to the stable set. Okay, so for hydrogen, the stable set is 2, while for C and Br it's 8. So I can verify here, for example, for this H, for any of the H, I have 2. It's the one of H plus the one shared with C, so it's 2 electrons, it's fine. For C, I have 4 bonds, okay, so it's 4 times 2, it's 8. And for Br, I have 1, 2, 3, 4, 5, 6, and 7, okay. So already it is 8. So because here we have 2 shared electrons, both will be counted for Br. And when you count, these 2 are counted for Br and also are counted for C. Okay, so in total Br has 8 also, so it's a stable configuration. Okay, so this is the molecule CH3Br. Any question on how we did the structure for CH3Br? Okay, now we move for O2. Okay, now for oxygen. So I have for O, what is the atomic number for O? If I go to the periodic table, so from the periodic table, the atomic number is 8 and the group is 6A. So since it's in group 6A, it has 6 valence electrons. Okay, so I can just now draw the Lewis structure of oxygen. So I have 1, 2, 3, 4, 5, and 6. So here I need a double bond. Okay, so oxygen with oxygen, I need a double bond between the two to reach a set of 8. So each oxygen atom will share 2 of its electrons with another oxygen atom. And in this way, both atoms will have a stable set of 8. Okay, so if I put for the other oxygen atom the electrons, then I reached a stable set of 8 for both. Okay, because always the shared electrons are counted for both atoms. So it's 8 for this oxygen and 8 for this oxygen. Okay, now we still have a molecule BF3. Okay,
Doctor,
so yeah,
what is the type of bond of CH3Br?
covalent. Okay, why?
Okay.
Because you have sharing of electrons. Whenever you have several atoms sharing, and it's atom to atom sharing. Okay, it's not what is, look, to understand more, if I go back to the slides, okay, you can see it more. You have 3 types of bonding, possible bonding between atoms. The first one is the covalent bonding. Whenever you have atom to atom sharing, okay, even if you can have several atoms in a molecule, but the sharing is based by atom to atom. Okay, while in metallic bonding, what is the difference? In metallic bonding, look at the figure. All electrons are common between all atoms, which is not, if you want, in this case, it's not an atom to atom sharing. No, you are sharing electrons by a block of several atoms. Okay, so this is metallic bonding. While covalent bonding, it's atom to atom sharing. Okay, so here, all, for example, all these electrons are common for all for all atoms of the molecule, which is not the case in covalent bonding. In covalent bonding, you have each atom can have neighbor atoms, and they are sharing their electrons, but not all electrons shared with all atoms. Okay, so this is why in C, the molecule we have taken together, it's covalent bonding, because you have atoms sharing together electrons. Okay, but instead